Good afternoon, all of you. In last lecture, I have discussed the study test for or the study testing of product. Today, we will continue the same point. That is the remaining part or the remaining point. That is the test for sterility of the product to be examined. The test may be carried out by using the test technique of filtration, membrane filtration, or by the direct inoculation of the culture media with product to be examined, and the appropriate negative controls are included. Then the technique of membrane filtration is used whenever the nature of product permit, that is for filtrable aqueous preparations, then for alcoholic preparations, then for oily preparations, and for preparations which are miscible or which are soluble with aqueous and the oily solvents. I am repeating here, the technique of membrane filtration is used whenever the nature of product permit, or that is for filtrable aqueous preparations, for alcoholic preparation, then oily preparations, then also the preparations which are miscible or soluble with aqueous solvent, or the miscible or the soluble with oily solvents, provided the solvent do not having the antimicrobial effect in the condition of the test. First, that is filtration, membrane filtration. The used membrane filter having the normal pore size is not greater than 0.45 micrometer, and whose effectiveness to retain the microorganism has been established. Then the cellulose nitrate filter, for example, are used for aqueous, oily and weakly alcoholic solution, and the cellulose acetate filter, for example, strongly alcoholic solution. Then specially adapted filter may be needed for certain products, for example, antibiotics. Then the technique described below assume that the membrane about 50 millimeter in diameter will be used. If filter of different diameter are used, the volume of dilution and the washing should be adjusted accordingly. Yes, what I am saying, if the filter of different diameter are used, the volume of dilutions and the washing, it should be adjusted accordingly. Then the filtration apparatus and the membrane are sterilized by appropriate method. Then the apparatus is designed so that the solution to be examined, and it can be filtered and it can be introduced and filtered under the aseptic condition. It permits the aseptic removal of membrane for transport to the medium, or it is suitable for carrying out the incubation after adding the medium to be appropriate itself. Then method of test, first, that is aqueous solution. If appropriate, transfer a small quantity of suitable sterile diluent such as 1 gram per liter in neutral solution of meat or casein peptine having the pH of 6.9 to 7.3 onto the membrane in the apparatus and the filter. Then the diluent, it may contain suitable neutralizing substances and add or appropriate inactivating substances, for example in the case of antibiotics. Then transfer the content of container or the containers to be tested to the membrane or the membranes. Then if it is necessary, after the diluting the volume, used in the method suitability test with the chosen sterile diluent, but in any case using not less than the quantities of the product to be examined. Then filter the immediately if the product has antimicrobial properties. Wash the membrane not less than 3 times by filtering through it each time the volume of the chosen sterile diluent used in the method suitability test. Then do not exceed a washing cycle of 5 times 100 ml per filter, even if during this method suitability it has been demonstrated that such a cycle does not fully eliminate the antimicrobial activity. Then transfer the whole membrane to the culture media or cut it aseptically into the 2 equal parts then and it is transferred one half to each of these two suitable media. Then use the same volume for each medium as the method suitability test. Then alternatively, transfer the medium onto the membrane and the apparatus and incubate the media for not less than 14 days. Then we will see in the charts here. The chart shows the minimum quantity to be used for each medium. That is, first column shows the quantity per container, and second the minimum quantity to be used for each medium unless otherwise justified and authorized. First, liquid less than 1 ml, 1 to 40 ml the whole liquid less than 1 ml the whole content of each container. Then 1 to 40 ml, then half the content of each container but not less than 1 ml. Then if greater than 40 ml and not, then it 20 ml, and not greater than 100 ml, then it is 20 ml. And if it is greater than 100 ml, the 10% of content of the container but not less than the 20 ml. Then for antibiotic liquid 1 ml, insoluble preparations, creams, ointment to be suspended or emulsified, use the content of each container to provide not less than 200 milligram. Then solid less than 50 milligram, the whole content of each container. Then 50 milligram or more than 50 milligram or more but less than 300 milligram, half the content of each container but not less than 50 milligram. Then 300 milligram to 5 gram, then it is 150 milligram, and if it is greater than 5 gram, then it is 500 milligram. These are the minimum quantities that are used in different medias. Then for soluble solids, first I discuss the aqueous solution. Second, that is soluble solids, used for each medium not less than the quantity prescribed in table, but the product dissolved in suitable solvents such as solvent which are provided with preparations. Then water for ingestion, sodium chloride, peptone, and proceed with the test as described above for aqueous solution using a membrane appropriate to the chosen solvent. Then third, that is oils and oily solutions, use for each medium not less than quantity of product prescribed in about, as I said earlier. Then oils and oily solutions of sufficiently low viscosity may be filtered without dilution through a dry membrane. Then viscous oils, it may be diluted as a necessary with a suitable sterile diluent, for example isopropyl myristate, and it does not show or does not have the antimicrobial activity in the condition of the test. Then allow the oil to penetrate the membrane by its own weight, then filter, then applying the pressure or suction gradually. Then wash the membrane at least 3 times. Then wash the membrane at least for 3 times. Then by filtering through it each time about 100 ml of suitable sterile solution such as peptone, then containing a suitable emulsifying agent at a concentration shown to be appropriate in the method as it is suitability test. Then for example polysorbate 80 at concentration of 80 gram per liter. Then transfer the membrane to the culture medium or the media, or vice versa. It means culture media to the membrane or membrane to the culture media, as described in same method, that is above method, that is aqueous solution method, and incubate at same temperature and for the same time. Then next, ointments and creams, use for each medium not less than the quantity of the product. Ointment in a fatty base and the emulsions of the otorine oil type may be diluted to 1% isopropyl myristate, and by heating if it is necessary, and in exceptional cases it may be necessary to heat to not more than 44 degrees Celsius. Then filter as rapidly as possible and proceed as described in the above method. Then direct transfer sterility testing. Direct transfer sterility testing. The direct transfer sterility testing method is the method of choice for the medical devices and non-filterable pharmaceutical products, which includes the solid dosage form, powders, ointments, and creams. In this sterility testing method, test articles are directly transferred into the fluid directly transferred into the fluid thioglycolate medium, that is FTM, and capital S CDM, that is soybean casein digest medium. Then both media are incubated for 14 days and checked every day for the presence of microbial growth. Then direct inoculation of the culture medium, transfer the quantity of preparation to be examined into the culture media so that the volume of the product is not more than 10% of the volume of the medium unless otherwise it is prescribed. If the product to be examined as having has antimicrobial activity, carry out the test after neutralizing this with a suitable neutralizing substances or by the dilution in a sufficient quantity of culture medium. Then when it is necessary to use a large volume of the product, it may be preferable to use a concentrated culture medium prepared in such a way that it takes account of subsequent dilutions. Then, where appropriate, the concentrated medium may be added directly to the product in its container. Then, method of test: oily liquid, ointment and cream. For oily liquid, use media to which have been added a suitable emulsifying agent, then agent at a concentration shown to be appropriate in this method because it is suitable to test. For example, polysorbate 80 having the concentration 10 gram per liter. Then ointment and cream, prepare by diluting to about 1 in 10 by emulsifying with a chosen emulsifying agent in suitable steroid diluent such as peptone. Then transfer the diluted product to a medium not containing a emulsifying agent. Then incubate the inoculate media for 14 days or not less than 14 days and observe the cultures several times during the incubation period. Then shake the culture containing oily products gently for each day. Then, however, when fluid thioglycolate medium is used for detection of anaerobic microorganism, keep shaking or keep mixing to a minimum in order to maintain the anaerobic conditions. So this is all about these sterility methods. Next we will see the observation and the interpretation of result. At interval during the incubation period and its conclusion, examine the media for microscopic evidence of any microbial growth. If the material being tested render the medium turbid, so that the presence or the absence of microbial growth, it cannot be readily determined by use of or by visual examination. The 14 days after the beginning of incubation, transfer the portion, that is each not less than 1 ml of the medium, to fresh vessel of the same medium and then incubate the original and transfer the vessel for not less than 4 days. Then if no evidence of microbial growth is found, see here what I am saying, I am repeating here. If no evidence of microbial growth is found, the product to be examined, it complies with the test for sterility. Then if evidence of microbial growth is found, the product to be examined does not comply with the test for sterility unless it can be clearly demonstrated that the test was invalid for causes unrelated to the product to be examined. Then The test may be considered invalid only if one or more of the following conditions are fulfilled. There are few conditions. First condition, that is the data of the microbiological monitoring of the sterility testing facility show a fault. Then second, a review of the testing procedure used during the test in a question reveals a fault. Then third, microbial growth is found in negative control. Then after determination of the identity of the microorganism isolated from the test, the growth of the species or this species may be described unequally fault with respect to the material or any technique in the procedure. Then if test is declared to be invalid, it is repeated with same number of units as in the original test. Then if no evidence of microbial growth is found in the repeat test, the product examined complies with the test for sterility. If the microbial growth is found in the repeat test, the product examined does not comply with the test for sterility. Then incubate the media for 14 days. Then here we can see the flow chart for this. Incubate the media for 14 days. Then examine the media for microscopic evidence of microbial growth during the incubation period. Then transfer portion, that is each not less than 1 ml of media to fresh vessel of the same medium. Then incubate the original and transfer the vessel for not less than 4 days. For that there are two observations. First, if growth is not observed, and second, if growth is observed. If growth is not observed, then passes the test for sterility, and if growth is observed, preparation fails the test for sterility. Then if it test is declared to be invalid, then repeat the test with same number. Yes, what I'm saying, if test is declared to be invalid, then repeat the test with same number of unit as in the original test. Then there are two separate observations: no growth of microbes, and the second, that is microbial growth is observed and confirmed microscopically. If no growth of microbes, complies the test for sterility, and if the microbial growth is observed and confirmed microscopically, then the sample does not comply with the test for sterility. So this is all about the sterility testing of pharmaceuticals and the observation and the interpretation of result.